still on.
All right, we got this here business about our air conditioning, and everybody that has ever driven a car without air conditioning knows that it's not fun. But used to, climate control system, this the other day, took like 3 to 5 pounds of refrigerant in the old days, and now they've been slashed to the point that most of them have refill capacities of less than a pound or about a pound. All right, so cabin air filters is another thing that's been more and more common since about 1995 when they appeared on the Ford Contour. Some of them are outside under the hood, behind this vent in front of the windshield, and some of them are inside behind the glove box. Some of them, like on the Altima, like I say, it's right up in the middle, right up over top of the center of the dash, up against the firewall. You got a little piece you got to take off. Some of them, they want you to add it if it's not there on, some vehicles. So there's all kinds of weird stuff about cabin filters. More of the air handling doors in the dash are driven by electronic servos. S-Class Mercedes has 10 of those things. And that's basically, you got all these different motors and flat actuators and all that kind of stuff.
The new Ford trucks has got 4 of them. You got to pull the dash out same.
That's not unusual. Usually the dash has to come out to change most of them. That Mercedes S-Class uses stepper motors. Each motor has one power feed and several separate grounds, and the stepper motor pulses the ground inputs across the ground to rotate the motor core like the way GM and Chrysler does their air control motors. That way, they can stop it anywhere they want to, right? So all of them are identical. All of them are just alike. The task of the actuator motor and the assignment of the flap takes place via the wire harness coupling. Now what they do on a lot of these, they'll actually have all of these actuators are exactly the same, but they'll have some little jumpers in the connector that jumps 2 pins that tells the actuator what it's supposed to do, which is pretty interesting how they did that, and that's a Mercedes thing there. But anyway, you got a lot, even no frills vehicles. Why in the world, what did they used to do before they had actuators on the blend doors so that you could have cold or warm? You remember? Like, ever since there's been a car with a heater and an air conditioner on it, you basically had a little slider or a knob or something where you could turn it from cold to warm. How did they used to work before they had electronic blend door actuators?
Vacuum.
Well, sort of, but you can't just stop that vacuum anywhere between cold and warm, can you?
I remember replacing one down there, it was all vacuum.
Yep. I'm going to have to let that one go by. I'm not going to answer this phone this time. All right, so as many different types of door actuators and systems as there are vehicles. There's just all kinds of different ones over here. All right, many manufacturers are using clutchless compressors with electronically controlled swash plates. Okay, and they're equipped with a rotary valve, see it down there, that in the rear of the compressor that's electromagnetically controlled to feed refrigerant pressure into a special chamber that causes the angle of the swash plate to change. The more that swash plate is changed, the more farther those pistons move and the more it works. Well, when it's dead in the center, you don't have any compressor operation. Now, this right here is a clutchless compressor. It does not have a clutch that engages and re-engages. It does everything it needs to do by moving that swash plate on the inside of the compressor. And here's various different types of, the ones that have the swash plate that's movable like that. This is a sort of a diagram on that one. This one right here would be like for a hybrid compressor. See, it's got an electric motor built into it, and it'll have a scroll compressor part up there in the front. So you got to use the right kind of oil on those, or you'll take the insulation off the windings and shellac, and you'll cause trouble with that. So these usually have a couple of 100 volts going to them.
What would happen if one of them compressors without the clutch, like a bearing or something locked up in it?
Well, basically, you just have to pull the hub off and put a bearing in it like you would. But usually, if the bearing locks up, you can buy the bearing.
Well, what I'm saying, if it locks up and you're out on the road somewhere, it's gonna burn the belt off, ain't it?
No, it's got a breakaway thing in there.
Okay.
It's got some little breakaway deals, and whenever if something like that happens, it'll just pop those. Well, if the compressor itself locks up, it'll break those. But if the bearing locks up, you're not any better off with a compressor with a clutch. If that bearing locks up, you're still in bad shape.
You can just disengage it.
Huh?
Can't you disengage it? No.
No, because the bearing is always working. But anyway, here's then you got your scroll type compressors, there's those scrolls in there, we talked about that the other day. So I'm gonna focus a little bit on the Sonata, and these are the Sonatas that are, like 5, 6 years old and up to a little bit, they're a little bit different as you go up, and not all of them are exactly the same. But you got an evaporator, you've seen that before, where heat's absorbed, and you got your compressor. You see how all this works if you've been here before. You notice how on the expansion valve, like I've talked about before, you have both the suction line and the liquid line both go through the expansion valve. All right, and so the expansion valve is basically going to change the size of that orifice based on the temperature of that. Anyway, here's your heat's being removed to the condenser and so on and so forth. And then you got your receiver dryer there. And so that's not a big deal. So what is AQS? You ever heard that before? This is what the control panel looks like if it's got AQS. This is what it looks like without AQS. So tell me what AQS is. Anybody know? As far as it relates to air conditioners.
Let me look it up for a second.
Huh?
Yeah.
Do the words air quality sensor mean anything to you? Air quality sensor? Now, why would you want an air quality sensor? And what would an air quality sensor do? What's an air quality sensor going to change? It's got a job to do.
The quality of the air.
Huh?
The quality of the air.
Meaning, what would be bad quality air?
It's recirculating instead of coming out on the outside.
Exhaust fumes. Smart guy. Okay, so the air quality sensor is smelling the air coming in the front of the car. So what's it going to do about it if it smells air it doesn't like?
Bring fresh air in.
No, it's
Well,
going to
that's where it's
close out the
using
fresh
fresh
air and let you put you in recirc automatically. So you don't smell that truck that's stinking up there in front of you because it's not running right or whatever. And now I will tell you this, the one thing that it cannot smell is a rendering truck. A rendering truck hauls away dead cows and stuff. And it doesn't know if it's something that's gonna stink to you, but if it's got something like this related to emission controls, it can deal with that. All right, now here's the air quality sensor. Automatically changes the air inlet to recirculate when it detects exhaust gas from other vehicles. It's mounted out there in front of the radiator, right next to the ambient air temperature sensor. And the operating voltage is 9 to 16 volts DC, rated at 12. Operating temperature is minus 22 to 221. And it detects gasoline engine exhaust. It detects diesel engine exhaust. And it detects, and its reaction time is less than 1 second. As soon as it smells something it doesn't like, it changes it to recirc. Now that's something you're going to see particularly on these Hyundais. I don't know how many other vehicles have those, but I'm sure there's somebody besides Hyundai that's using them. The ambient temperature sensor looks suspiciously like an old Ford part to me. All right, so basically you got your, automatic temperature control there, and you got your sensor there, and then you got a reference voltage, 5 volts being read out, and it's reading the voltage right there. And this chip is doing something with it, and the automatic temperature control makes decisions based on it. I'll talk a little more about that in a minute. There's your 3D layout of the two different ones. This would be, one of these would be like your Sonata, the other would be like a Tucson, whatever. Yeah, so, but right here we've got a fin temperature, evaporator temperature sensor, and it prevents the evaporator from freezing up, and it's inserted into the evaporator fin, just poked in there. As a matter of fact, there is the one that Lee had to replace that one for that fellow that came in here. And there was a bulletin that came out of the box when he opened the sensor. Either that or we got one from an Inafix, and it said to put it in a different place. And so we did that. And we replaced the fin temperature sensor, or the evaporator temperature sensor on this 2010 Ford Focus out here, but it's still freezing up. That's usually what causes it to freeze up, because it doesn't know that the evaporator is really cold. And what I managed to find on that Focus, of course we did that last fall, and now she's actually been just cycling it by hand because it gets really cold and it freezes everything up. She loses her airflow. But what I found was that with the IDS, we can reflash that unit and fix that possibly, because it's like a programming error. If we can do that, then she'll be a happy girl. But we're also doing the brakes on that car right now. Anyway, this is the characteristics of that. at various temperatures and, you know, in Fahrenheit, this is what the voltage is gonna be. That is a useful little table if you're troubleshooting one, that, you know, to see if it's working right. You know, the in-car sensor is located in the control panel, and there's an aspirator. Have you ever seen these little grill parts on the dash, and you wonder what it was for? Somewhere on the dash you'll see one of those. That Cadillac, that red Cadillac's got it. It was far back as '71, and basically there's an aspirator, and what they do is whenever you put an aspirator into the airstream and there's air flowing through the stream, it actually will pull inside car air across this sensor and down into the airstream. If you didn't have that, it wouldn't be able to accurately measure in-car temperature. So basically that's where it's at. You know, it pulls air in there and it goes past that sensor, and it can sense the temperature, change the resistance value, and it enters the corresponding voltage into the automatic temperature control module. That's an aspirator hose type sensor like I was talking about. You got a sun load sensor. Here we've got a light sensitive sensor. Some of you guys, if you remember in electronics, I've got a little sensor in my little bag of tricks there that you can basically hook a meter up to it, and you can shine a light on it and it changes resistance. And so if you got more of a, how many of you guys have ever been riding down the road with somebody and the sun's coming in one side of the car and the person in the hot side of the car is wanting to turn the air on, while the person in the shady side of the car is getting too cold? You know what I'm saying? The hot side of where the sun's baking the guy, he wants to turn it up, and his wife's saying, I am freezing over here, you're freezing me out, you know. Well, the sun load sensor kind of helps with that. That's basically what it does. You know, so you got a photo sensor up there, what it basically is. And so, but you can put a 60-watt bulb here and shine it on that thing and get an idea of what it is that you're going to be reading there. You know, so if you want to test it, you can do that. What does the trucks like the one you drive, Zane, and that white one, and the GMC, they have a sensor too, a light sensor. What is it used for?
Lights.
He's right.
Yeah, no, mine's got.
He wasn't being a smart aleck.
For the automatic headlights.
Yeah, I mean, whenever you've got a daytime running lights, when you back it outside and you're driving it, after about 45 seconds, it turns on the daytime running light because it sees the light. If you're in the shop and you want to see if that will work, all you got to do is lay your drop light up on the windshield over it and wait a little bit and see if they come on.
Is that what that red, is that blinks red? Is that
No, that's actually for the passive anti-theft.
So where's it at then?
Well, it's that, oh, you mean that, excuse
That's
me.
what I'm trying to.
Oh, yeah, well, and sometimes you'll see a little bubble looking
Yeah.
thing sticking up, you know,
That's about the way around the car.
or about a little.
So it's like, yeah, that's what I was thinking about.
Yeah.
Mine's got a little red light in it too though.
Yeah, it does. I mean, yours, you probably got both of them together on that. And that little red light, when it's blinking, it blinks on and goes off. But if it's going blink, 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 and your truck won't start, that's the reason. Of course, you gotta go find out why it's blink, blink, blinking anyway, one way or another. But when the vehicle's not moving, the ambient temperature sensor is affected by heat radiating from the ground and the radiator. And that results in an inaccurate ambient temperature reading. So the Tucson for automatic temperature control is controlled to ignore the ambient temperature sensor readings when the vehicle speed sensor indicates the vehicle is not moving. If we know you're not moving, it doesn't pay attention to that because it knows it can't trust it. And so it remembers and displays the last temperature it recorded when the vehicle is in motion. Well, basically, that may be a value that's held. You can imagine how stupid it would be if you stopped at a red light and your ambient temperature went up to 118 degrees or 125 or something like that. It's not going to read that, you know, so that's the whole thing. Okay, hello, give me the next slide. Where are we at? Okay, now here's a Sonata temperature actuator. The 5 wires are orange, see the orange wire, position sensor reference, gray, position sensor signal, pink, position sensor ground, white, motor control, and yellow, motor control. Now your motor control wires are the ones that drive it back and forth. So basically, your position sensor reference is going to be a voltage number, like 5 volts or whatever, and your gray, your signal, your sensor ground is going back to the module. But this is the one that changes whenever the position of that motor moves. Okay, the intake air actuator is really similar to the temperature actuator. There's a wire plugging into it. Orange is position sensor reference, blue is position sensor signal, pink is position signal, brown and black is motor control, green's motor control. So your motor control wires are gonna be different colors on that. Now, on this GMC out here, if you know where to go, you can basically go in there, and on that one, you got some little wires in there, and you're gonna jump your 5 volts to a different pin. You know, like you can jump it back and forth from one pin to the other and drive it back and forth while you're hooked up to the little potentiometer in there with a meter, and you can tell with your little meter as you drive it back and forth if it's operational or not. That's another slideshow for another day. All right, the mode door actuator has to move more than one door, so it drives a transmission plate with curved slots to connected levers. You've probably seen this kind of thing before, but that's called a transmission plate, is what you call that. Now that actuator can be checked visually for movement while mode changes are commanded, so if you're turning the knob, you can see if it's going back and forth like it's supposed to. Now be really careful when you're working on this stuff with these actuators, because sometimes whenever you can take one of these things, like on that one of Gene's or these Fords, that's a little blend door actuator off Gene's truck that quit working, and you can basically, you can turn it, and you can, this thing gets hooked into the blend door is supposed to move back and forth as you turn your knob back and forth, but there are some units that if you got to make sure that it's okay to do this, because there are some of them you can turn it whenever it doesn't have any resistance, so it'll stop, it can get out of phase and quit working. Somebody bump Jonathan and wake him up. Okay, basically that's what that's all about over there. All right, come on. Now this is the typical layout for a door actuator on one of these Hyundais, and it's not a whole lot different from your other ones. And so basically here's your motor control wires that I was talking about, and this basically right here, you got a sensor ground. Now this is odd because they got ground coming in from the top, so you know our Korean friends sometimes don't follow the same rules that we do. But anyway, here's your 5 volts. So if I was going to draw this, I would find a way to bring the 5 volts in the top and have the sensor ground coming from the bottom, but whatever, okay? And there's that deal on that. Engine control systems have been using that way for throttle position sensors and other kind of things for years. And also you've got some of your actuators for ride control that do stuff similar to that. When checking the operation though, the signal wire can be measured for voltage changes while the control head knobs are being manipulated. So if you go to the signal, you know, the wire that's going to change, which is going to be that one there, you can take your meter and hook into that one, and you can turn the knobs and see, you know, if that voltage is changing up and down and all that. And, all right, now you gotta love them for giving us a layout. This is really beautiful how they do this. Some of these automakers will give you a really gorgeous layout on this right here and tell you exactly where everything is and how you can find your relays and all that kind of stuff. But the PCM controlled AC relay is third from the right on the bottom row. A red 10 amp fuse just above it feeds the common terminal on the AC relay, and the Hyundai folks have provided a vacant 6mm power junction stud for accessories on the top left. If you want to hook up your boom box, you can hook it up right there. Pretty slick how they did that. They keep people from jacking around with stuff. But the coolant fan fuse, while it's easily accessible, the coolant fan relay is buried under the battery tray, and you got to take the battery and the battery tray out in order to take that fan relay out of there. Now, Hyundai wanted a gutsier connection to drive the fan, so they didn't want to do that through the junction box. But now this right here is this peculiar. That's not a very clear schematic, but you got an engine control relay there. Your coolant fan assembly is right here, and then you got this. They got a crazy deal here that operates that coolant fan module, so that it can control the speed of it and everything. And whatever speed the PCM is deemed appropriate, it'll drive it that way. Now you've got a fin temperature sensor. The water temperature sensor helps the, well, not just a fin temperature sensor, that's in another, that's up here. But there's a water temperature sensor down low. The evaporator fin temperature sensor is up here at the top. But it helps to control and prevent evaporator icing on manual and automatic systems. But you also got a water temperature sensor. Now where does the water come from? Huh? Is it measured in water in the heater core?
What are we talking?
Huh? It's in the bottom of the evaporator housing. So what's in the bottom of the evaporator housing? there's water down there when the AC's running. Why is there water down there? Where's the water
Because
coming
it's
from?
sweating.
Sweating like a glass of tea, right? And it keeps sweating and it runs off there if there's a lot of humidity. Now, some of these vehicles got humidity sensors on them, so that they'll know what the humidity is and all that. There was this guy one time when I stopped out there at the on Park Avenue, at that store that used to be the Big Little store out there. And I was walking by there, and this guy had parked his car there, and he noticed a bunch of water pouring from under there. And this other guy that was a self-proclaimed, expository mechanic teacher, was saying, that is a freeze plug. You got freeze plugs in the side of your block and all that, and whenever they rust out, they start to leak and all that. And he was just really giving that guy a lesson on freeze plugs, and that guy was really looking worried. And I looked at it, and it was just clear water, and you could tell it was coming out of the evaporator drain. And I said, that's not coming out of a freeze plug, it's coming out of the evaporator drain. He goes, oh yeah, evaporator drain. That's this little tube that you got over here that catches. He immediately changed gears and started explaining evaporator drain, never missed a beat. I don't know, for some reason that just.
So he knew about the stuff, he just didn't know what the diagnosis.
He just jumped on it saying it was a freeze plug, and then he realized, well, that's what it is. I mean, he didn't argue with me, he just jumped and said, oh yeah, the evaporator drain, that does this and this. Yeah, he wasn't dumb. He was telling the guy the truth about what he was talking about, but it wasn't, and on a really, really humid day, we have let cars run out here in the heat of the summer sometimes with the air conditioner running a long time to make sure that they were finding a problem, and but you better put a drain pan under that doggone plug, and it will fill up a drain pan with water on a cold day, dehumidify and all that air that's coming through there. Well, we put a big old drain pan under, because if you don't, you're gonna have.
Ain't got no water, turn the AC on, throw a drain pan on.
There you go. That's right. Yeah. Well, you better have a clean drain pan. Yeah. You could just crank the car up and go to the store, couldn't you? There you go. And get you a bottle of Zephyr Hills or something. Now, the air quality sensor that's mounted in front of the condenser next to the ambient air sensor, thanks for running the words off the end there, Rachel, can smell hydrocarbons and allergens according to the shop manual. And then we already talked a little bit about that, but the reaction time is just less than 1 second. Now, this is a friendly little system. Now, I will tell you this.
Why are they crooked?
Yeah, why's it all crooked?
I think that thing is crooked. I think that needs to be,
None of the other
It
sides
just
is
failed,
crooked.
didn't it?
they've all been crooked.
No.
No,
Yeah.
Go back.
Go back like 2 slides.
Crooked. Okay.
Second-rate amateurs didn't notice it was crooked until almost the end. Yeah, that's what it is. All right, we got to spend an extra 20 minutes in here now, just because of let me go back to.
Yeah.
But anyway, the 2-digit codes, when they're available on some vehicles, are a lot more general than the B codes. Now, when I say 2-digit codes, whenever you're doing your, like if anytime you're working on one that's got any kind of automatic temperature, see all them control heads I got laying up there that we've had to change out? Typically on that kind of control head, there is a little dance you can do on the buttons, like you put, off, warmer, and auto or something like that. It's not the same on every car. I mean, Cadillac used to have their automatic temperature control head set up so you could convert it to a scan tool right there on the car and read different scan tool PIDs. The craziest thing I've ever seen. Now you couldn't read but one at a time, but you could pull codes and all that. But on this automatic temperature control, the way Lee wound up finding what was wrong with that Tucson is he basically did that dash button dance, and it gave him the code that led him to the ambient temperature sensor. However, what you got to do on your control panel, you turn it, to convert it from off to on. You press the off switch more than 4 times within 2 seconds while pressing the auto switch. So you're going to hold the auto switch and press off, like that. And all the graphics in the display blinks 2.5 seconds, and they start self-diagnosis. And what self-diagnosis does, it sweeps all the doors back and forth, and it makes sure they can go everywhere they're supposed to go. Pretty handy that it does that. Now this is not just on this one, it's on a lot of different vehicles. That Crown Victoria, then we had to put Daniel put that blend door actuator on that Crown Victoria, remember that? We did that on that. I thought
that was Madden.
Maybe it was. One of those guys did that, but the long and the short of it, we found it by punching that. It didn't have any heat. All right, so Basically, you go on through that and you can pull your code. Now, this is the correlation between that. 11, 12, 13, 14, all the way down. You see your B codes, like if you're using a scan tool. Even if you don't have a scan tool, you can pull it. On some of the Jeeps, I have seen those, like in about the 2000, 2001 range, or maybe 98, 99, you could turn the key on 3 times and it would give you the powertrain control module code on the odometer, which is pretty slick. You know, the older ones, whenever you had a power loss light, which was kind of like a check engine light, you'd turn it on, you know, click, click, click on 3 times and it would blink the lights and, you know, give you the 2-digit codes, and then the last code you get was like a 55, which told you there weren't more codes in there. But anyway, the evaporator temperature sensor, open, high, they can be shorted or open or whatever, you know, and that basically is pointing you in the right direction. A 2-digit to scan tool calibration. And then basically one of the most interesting developments is this little, and I drew this myself on paint. And basically the way you got that is, you got your hot gas coming in, your condenser portion of it basically turns it into liquid, and then it goes through here, through this little modulator, and the subcooler portion of it cools it off, so the outlet of this thing is going to be putting out cool liquid refrigerant instead of like they used to be. And they call this a subcooler, so if anybody's talking about a subcooler, you know, the mechanic, he's going to call it a condenser, the manufacturer calls it a subcooler. And so whenever you're ordering a part, if you have to get it from the manufacturer, you're going to need to be called a subcooler. These have a small receiver dryer in the liquid line, like other expansion valve equipped units, and it's designed to allow the hot liquid refrigerant to get rid of a little more heat, and it makes it run cooler, you know, basically. All right. Okay, so make sure that you turn on your you turn your notes in and all that, and then I will give you a grade. And if you have